So this is a continuation on how to get started with the Raspberry Pi Pico and how to get simple components set up. All the components from this video series is going to be pulled from this startup kit. I've linked in the video description and it includes everything that you're going to need to start off, including breadboard and jumper cables. Now, if you're not familiar with a breadboard, this is a half version. A full version is included in the kit. You're also going to want to have a Pico with header pins installed. You could solder your own on, or I've included a link with pre-soldered pins on Picos. Now, the first time you push it in, it'll be a little bit snug. So if you've never used a breadboard before, I'll give a quick overview. The highlighted pins here mean that they're all connected. So when I click on this row, all of these 5 pins will light up, meaning they're all connected. Now, when I click here, all the way down that row are connected, and all the way down that row are connected. So you can see here, each one of these pins, when it lights up, means it's connected to the other pins that are lit up. Now we're going to start off with wiring up power to the outside rows. And we're going to do that by selecting the 5th pin down, which is 3 volts. You can use the Pico pinout that I've included on my GitHub page, linked in the video description, for your guide for which pins mean what. So now we've lined up a ground also to the other row. The outside rows are generally used for power supplies. Most devices work on either 5 volts or 3.3 volts. The Pico uses 3.3 volts, but it can supply 5 volts if plugged into a USB. You can see I've already started wiring up an LED. You can tell which lead of an LED is positive because it's longer than the negative. Now you can't directly wire it up like this. This would burn out the LED and possibly the Pico too. Most LEDs work off 2 volts or maybe a little less, and the Pico is providing 3.3 volts to the LED. Also, the LED is going to want to draw 20 milliamps, and the Pico could only safely provide 12 milliamps. So that is where probably the Pico will get burned out. Now, to solve this problem, we're going to add a current limiting resistor. Now, you can either place it on the positive or negative lead, but I think I'm going to place it on the negative lead, as I normally do that when I'm wiring my own circuits. Now, in later videos, I'll show you how to calculate the value of ohms that you need for your resistor, but in this case, we're just going to set it at 550. Now, any value from 200 to 1K will work. Anything higher than 1K or 1000 ohms will make your LED look a little dim, but as you can see here, that works great. The only problem being is that it's always going to be on. Now, we're going to wire it up to the bottom right pin on our Pico, GP16. So now that we got the LED properly set up so it won't burn out either the LED or the Pico, let's add a push button to it. So a simple push button is got 4 pins, left and right being not connected unless the button is pushed down. To wire it up, we'll connect it to the Pico on the other side, GP15, and we'll connect it to positive. Now, wiring it up like this will work on the Pico if you're using the internal pull-up resistors, and I'll show you what I mean. Right now, the switch is left floating, meaning it doesn't have a state when the button is not pushed. It won't be positive or negative. So what we're going to do is we're going to add a resistor to pull it down, meaning when the button is not pushed, it's going to be connected to ground, giving it a 0 result or negative. We do this by adding a 10K resistor onto the same side of the button as the Pico is wired onto, tying the Pico to the ground. This means that when the button is not pressed, the Pico will receive a negative signal. Now we're going to be using software to do this, so we're going to remove that resistor, and you can see this is how our circuit should look all wired up. So now that everything is wired up, we're going to start typing our code using Thonny. Now all the code that we type up here is included on my GitHub page, which I've linked in the video description. And we start off with the first 2 lines by importing 2 libraries, machine and time. The next two lines, we're going to be setting up our two components. The first one being the LED on pin 15, and we're going to be setting it as a digital out. Next will be the button on pin 16, and we're going to set it as a digital in, and also we're going to set a pull down resistor on it. This was the resistor we removed earlier. Then we're going to set the LED value to 0 or off. Now we're going to set up a program by having a loop that checks if the button is pressed. We do that with the infinite loop while true, and then we set up a if condition underneath. How the if statement works: if the button value is equal to 1, it will be true. The LED will be value 1 or on. Anything else and the LED value will be 0. And that's it. Press play and take a look. Once you press the button, it'll turn the light on. As soon as you release, the light is turned off. Now let's say you wanted a program that when you press the button, the light will turn on and stay on, and then when you press the button again, it'll turn off. To do that, it's fairly simple. We're just going to save this program here, and then we will open up a new file. Now I'm going to save this as pushon.py. Py just stands for Python file. And I'm just going to go to File, New, and we're going to have a nice fresh slate here. So we're going to be starting off the same way, using the first two lines to import the libraries that we're going to be using, the machine library and the time library. Then we're going to be setting up our two peripherals, the LED and the button. We're going to be using the exact same settings as we did earlier. The LED as a digital out and the button as a digital in with a pull down resistor. But now we're going to be setting up a new variable called val, just short for value, and we're going to be setting it to 0. Now we're going to be setting up a infinite loop again, just like we did earlier, and a if condition for when the button is pressed. But instead of changing the LED value, we're going to change the value of the variable val by adding 1. And then we're going to add a small pause of 0.2 seconds. Then we're going to set up a secondary condition with the elif statement, where it's going to check to see if the value is greater than 2. If it is, it'll change it to 0, and then add a small time delay of 0.2 seconds. Then finally we set the LED value to value, which is either 1 or 0 now. So now with everything wired up, programmed and running, we'll give it a quick test. When you press the button, it should turn the light on and the light should stay on. When you press it again, it should turn it off. Now if you press and hold it, it's going to turn the LED off. As you can see here, it'll turn it right off. So now that's all fine and dandy, but let's say you wanted to have a program that when you press the button, it'll just turn the light on and off, or if you press and hold the button for, let's say, 2 or 3 seconds, it'll flash the LED as soon as you release. So we'll do that by starting a new file, by going File, New, and we're going to, again, import the same two libraries that we needed earlier, the machine library and the time library. And we're going to set up our two peripherals exactly the same way as we did earlier. We're going to use the LED on pin 16 and the button on pin 15. Again, one's going to be a digital out and one's going to be a digital in, and the button's going to have a pull down resistor. So now we're going to be setting up a while true statement, which just means all the code underneath, just like earlier, is going to run infinitely. Now instead of using a if condition to check if the button is pressed down, we're going to use a while loop to check and see if the button value is 0, which means not pressed. Now if it's not pressed, the code will then pass along to the next statement, which is time.ticks_milliseconds, which just generates a value, which is the number of milliseconds since the Raspberry Pico has been turned on. It'll use that number and set it to the value h, and then delay it another 1 millisecond. Now we set up another loop to check and see if the button value is equal to 1. Now we don't need to do the equal 1, but it just makes our code easier to read, so we will. So when the button is pressed down or equal to 1, it's going to pass down to the next line of code. The next line of code is now going to be a small arithmetic statement, which is going to use the master time, which would be the milliseconds that the Pico has been running for, and then it's going to minus the number of milliseconds exactly before the button was pressed. And this will tell the Pico how long the button will be pressed. It's a little bit confusing, but if you think it out, it makes sense logically, which is how all computers work. So now we're just setting up the condition if H is under 2000 or 2 seconds, then the LED will flash on and off for 1 second. And we do that by setting the LED off or on, and then sleep for a second, and then off again. So now if the button is pressed for anything under 2 seconds, it'll turn the LED on and off. And then for anything else, which would be pressed longer than 2 seconds, we want it to flash. And we'll set up a loop that will execute 10 times to do that. To do that, we use the for in range 10 statement. This means the code underneath this line will execute exactly the same 10 times. And we'll just add in the flashing code underneath, which will turn the LED on and off with a delay of 100 milliseconds in between. So now that everything is typed up, we'll give it a quick run, and you can see we have a typo, and we'll just change that to a dot here, and now we should be good. So now with everything typed up, we're going to see how this runs. We'll press it once and it flashes. Now we'll press and hold and see what happens. And there we go, it's actually flashing. So that's good. Now hopefully this has helped you out a little bit understanding how to wire up some devices to your Pico. If you're brand new to things, it could be a little overwhelming on how to get started. So I figured a video series on how to get you going would help a lot of people out. So hopefully this does, and please like and subscribe if you want to see more.